My research is focused on the Chinle Formation, and it's the major rock formation exposed at Petrified Forest National Park. It's late Triassic in age, and it's dated to between 225 and around 205 million years old. In this 25 million year time frame, I'm sampling vertebrate communities at around 2 million year intervals. And when I look at all those together, it gives me a high resolution picture of how change is occurring over long periods of geologic time. I'm using a technique called screen washing, and basically what you're doing is processing rocks from the field through a series of screens that screens out all of the fossil bone that was inside the rock, and then you're left with just concentrated fossil bone to work with. What I've been doing is using this technique in time periods in the Chinle that it's never been used before. And because of that, it's been resulting in a lot of new species and increased diversity of all of the animals that we know from the Chinle. We find in the field rocks that were deposited in a shallow lake or the deep part of a stream channel. Features like lakes and stream channels accumulate bone from the surrounding environment after animals die. That indicates to us that this might be rock that's worth processing. So we find fossiliferous layers in the field, and we'll take out blocks of rock, usually 300 or 400 pounds of rock from each site. The rock basically melts down in water, and the matrix, which is usually sand or siltstone, will melt away from around any objects that are in the rock, like pebbles or bone. This differentially sorts all of the bone and makes it easier to look at it under the microscope because all of the grains are of the same size. Generally, what I'm seeing, because these bones were deposited in aquatic situations, are fish scales. And another thing that's very common are teeth, because they're coated in enamel and they're very resistant to decay. What I'm very focused on finding are upper and lower jaws from reptiles, because the tooth structure and jaw structure is unique to the group of animals that the jaw was produced by. And jaws can tell you a lot about feeding habits, and so it can tell you what it was doing in the ecosystem. One group of animals that I've been collecting a lot of material from are Rhynchocephalians. Rhynchocephalians are very closely related to lizards and diverged from lizards evolutionarily around 250 million years ago. They look a lot like what a lizard looks like today. There's one living representative of this group left. It's the tuatara from New Zealand, and it's survived into the present day because it's been isolated on New Zealand and islands off the New Zealand coast. The data that I've collected so far in this project is giving good evidence that there was a major evolutionary change occurring in most vertebrate groups present in the Chinle Formation at around 215 million years ago. The next step I'd like to take my research is looking at whether or not major Earth system changes such as climate change, plate tectonic movement, or volcanism are acting as drivers for the observed evolutionary change.